Welcome everybody. My name is Alvaro Vives. I'm going to be moderating the next session. Is about IPv6 right now. So we will have three speakers giving a glance about how things are actually right now. We saw that there's a long history coming from IPv4 and moving towards IPv6, and let's see how things are actually. We will have Massimiliano, Max for friends. Speaking about our RIPE NCC Global IPv6 survey, that's quite interesting to see the results of the last one we made. Also, we were going to have Eric Vyncke with IPv6 statistics I mean, he is well known for his really good statistics, and let's see what he has to say to us. And last, we have Stephen from RIPE NCC explaining about 6 years of IPv6 on Atlas and Decay route, a couple of services we run here, and he's trying to figure out if there are useful information on the services. So also for the people that just joined us, let me briefly introduce the interface. You will see on the upper right corner the speaker's video, and the center, the bigger area, you will have the slides. You can make this area even bigger, maximize to see if you see you have a small screen, maybe it's useful for you. You have the chat that's quite useful to interact with us, make your questions, and you will see if you have anything to ask, you can use the chat for that. And also very useful for you, you have on the down there in the corner, you have also the presentations, all the PDFs or the presentations we are having today. Also, don't forget, well, we have a lot of people connecting. Maybe there are some issues with the sound or the video. Don't worry, everything will be recorded and posted on the RIPE NCC website, so you can lately take a look on all the contents we are having today here. So, not taking it longer, let's go to Max, that's going to present.
Everyone, now you should be hearing me. Can you give me my confirmation? Yes, I'm sharing my... Yes, okay, then I'll start sharing my screens. And what I'm going to talk about today is a survey that we've run, also together with my colleague Stephen and other colleagues from the communications department. The idea that we started with was that 6 years ago, and for now you know it, by now you should know it, there was World IPv6 Launch Day. So we wanted to see what the difference between then and now is or was. So what we did was we had a survey that was run around then, and there were different incarnations of this survey over the course of different years. So started in 2008, 9, then also 10 was a smaller one, 2011, 12, and 13. And we decided to try to run it again. In the past, it was run as an effort, joint effort from the NRO. So all the RIRs were supporting the survey. The data is available to all the RIRs, and actually, if you want to download it, it's available from the NRO website. I don't have a link here, but if you ask me later on, I'll be able to provide it. And there we decided to take it on, run the same exact survey. So we contacted Martin Botterman, the person who was behind the survey initially, and we did it again with SurveyMonkey. So this is the same presentation I did at the RIPE meeting a couple of weeks ago in Marseille, and also there I apologized to everyone because we ran the survey using SurveyMonkey, and literally 10 minutes after we sent out the announcement, we started seeing tweets of people complaining about us using SurveyMonkey because SurveyMonkey doesn't work over IPv6. Yes, we noticed, and we know we'll learn in the future, but that was the reason we ran it using SurveyMonkey is to keep data consistency with the previous surveys. So last week, in the end, we received actually a single file that we got from SurveyMonkey, and now we can do more deeper analysis on what we obtained in the last years altogether in the same data, so we don't have to play with it. Martin helped us run this survey, and we launched it at the end of February. We closed it officially on the 31st of March, although we also waited for some more results in April. I will pause 5 seconds. Yes? Oh, okay. What is wrong with my sound?
Your sound is saturated. So
okay.
We have to change your mic settings. Sorry.
1 second. We will fix. Yeah, does it sound any better? I'll keep on talking so you can now understand if it's better. Ah, okay.
Yes.
Perfect.
So
okay, perfect. No, that's fine. That's fine. There we go. Okay. So I was saying we launched the the survey at the end of February, closed it officially on the 31st of March, but we also waited for a few days because we knew some people were still sending in some results, some answers. So we actually got a little bit of them also after that date. In total, we ended up receiving 1,218 responses, which actually set us a little bit lower than what we had in the previous surveys. Why this? Looking back at what happened, it might have been because we marketed it. So all the emails, all the communications that we sent out mentioned the RIPE NCC Global IPv6 survey. So it could be that many people thought it was just RIPE NCC related, and if they were not aware of what the RIPE NCC does, they wouldn't fill it in. So this also led to the fact that we had 87% of the answers coming from our own region, which is almost, well, it's pretty close to doubling the number we had in 2013, which is both good and bad, because that means that we can have a better insight into what our own region does, but also it doesn't give us a nice overview of the whole world. So this is a lesson we'll have to learn for the next time we want to run a similar effort, when we want to do something along the same lines. But looking at the top countries, we see that not that much has changed. Like the top 3 countries are still the same, although with slightly different numbers. But then in the top 10s, we have pretty much the same countries. I see my good beloved Italy being there and growing from the 10th place to the 5th place. And I see my colleagues here are also joking about it. We see some new entries like Switzerland and Czech Republic. France was still there. France just jumped one position. But the thing is, India, which represents like a large part of the world population, doesn't show up in the top 10 in 2018, which is also something that we should look into for the next surveys. Now, looking at the basic data, a little bit more of demographics. What did we see? In the organization types, we didn't see much change. So we had around 50% of ISPs, and then around 10% each of content, education, and ICT. And then we had around 5% each of government, research, and other. So this means that between different surveys, we had an homogeneous type of answers, but this also means that we are good at catering to the ISPs. We should be trying to do better for contents, education, and ICT. But also, you know, government and research, they represent a very small chunk of the internet-connected entities there, so that's also normal that they are around the 5%. But we should do better with ICT and content in this case. Also, the customer base size. We asked the ISPs, so this was a question that we only posted to those respondents that told us they were ISPs. What's your customer base size? How big is it? And we had a good mix. No change, but the good thing is we had a 60% of them that told us they are small and medium. We had around 20% between 10,000 and 100,000 customers, and then 10% with more than 1 million customers. So this gives us a nice overview of the different sizes of the different different types of ISPs out there. Now, the obvious data. You heard Nicholas talking about how many of our members have an IPv6 allocation. We see here 85% answered that they have one, which is in line with what we see from our registration services department. The good thing is that from 2012 it went up 20%, and from 2013 it went up 10%, which means that things are still happening. So some entities who didn't have allocations back then, they went on and got one. So there's also an interesting part here. There was one answer you could give, which was, I don't have IPv6 because my infrastructure is hosted from a third party. It grew consistently. Why? Maybe because between 5 years ago, 6 years ago, and now, the cloud is a bigger name, a bigger word, and more organizations moved there. So this also represents some nice data we gathered from the survey. Now, looking at the reasons for not supporting IPv6, what do we see? The top 3 ones are unchanged. We see this, the important ones. People mention that the availability of knowledgeable staff is a problem. So they don't want to, or they can't move to IPv6 because they don't have knowledgeable staff. They can't find people who know their way through around IPv6. And we see this. I am in the training services department at the RIPE NCC. We see this whenever we give a training course. Our training courses are more and more popular because people want to learn about IPv6 more and more. Then, a very understandable reason, costs. And then, I think it's tied to this, the business case, they have to pitch to non-technical management for them to understand that IPv6 is a need. Now, another interesting part here is that vendor support. So, the reason people cannot move to, organizations cannot move to IPv6, vendor support hasn't changed in percentage between 5 years, 6 years ago, and now. And that was constant. We saw across all years. So that means that either vendors aren't moving that much, or they are moving, but new RFCs and new implementations are needed for supporting all the requested features. So this is also something that we'll have to investigate a little bit more in the future when we work more on the data we gathered. Now, transition mechanisms. First off, good thing is that more than 50% of the respondents said they don't use any. So they just go either dual stack or IPv6 only. But we also see that NAT64 has a big chunk of the market, followed by 6RD and then DS Lite. And then those 2 little colored parts you see are MAP, E, and T. And they are, I think there were 2 respondents who mentioned, 2 respondents each who mentioned they're running MAP as a means of transition mechanism. Now, the good news, there's a very, very good news, is that we ask people, what do you think, what would you think of using or plan to use as carrier grade NAT with or instead of IPv6? So instead of IPv6 got down from 8% to 0%. And as you can see, it's been a constant decline across years. Now, no one said that they will use carrier grade NAT along with IPv6, but instead of IPv6, but they want to use it along with IPv6. So apparently it's not seen as a way of avoiding IPv6 right now. Yes. So, but one thing, sorry, they just mentioned that I should have moved my mouse because it was in the way. Now, we wanted to check this data around. We asked ourselves, can we do a quick reality check? Can we see if this data matches what we see in some statistics? So we had a question in our survey that asked what is the percentage of users or customers you have on IPv6? So what we did was take it, create a heat map divided by country, and then check it against the data from Google, from Eric. Eric Vyncke is going to talk in a moment about his own statistics. We have the statistics from APNIC and our own ripeness. So what did we see? Here's a heat map from 2013. I know all the numbers are small, the name of the countries are really small, but I'm going to move to the next slide in a moment. The next slide, and these were all generated by work by Stephen, who's also going to talk later in the same section. You'll see that basically the higher we go here, the more users you have on IPv6, and the darker it's colored, the better it is. So look at this. When I move from 2013, the data we got from 2013 to the data we got in 2018, there's more, there's darker color, there's more on the top, and that's actually a better sign. So going back and forth between the two slides, you'll see how much that has changed. Now, what can we learn from this? At the RIPE meeting, before me, there was Geoff Houston talking, and he mentioned in his statistics, in what he was seeing, some countries. And I was glad to go on the stage, and you can also watch the video there, and actually mention the same exact countries that we see in our statistics. They were basically up here. We took a small sample. The United States, very high in this area. United States have lots of mobile networks that have a very high percentage of traffic and users on IPv6. We see the UK. Sky Broadband has also a high percentage of IPv6 penetration there. We see Switzerland with Swisscom and other smaller operators all doing IPv6. And we have the Netherlands, where also you have some operators doing IPv6. So this data helped us get a quick confirmation that we can now then look into the data in our future work with more analysis coming. We're going to share the data internally, and we've already done it with some other colleagues from other departments, and we're going to work with them to identify the interesting data we want to show in the coming weeks or months. And so you'll be hearing more and more presentations about the Global IPv6 survey. So now I think it's time for questions. Shall I ask Alvaro if there's anything?
Yes, if somebody has any question, please put on the chat, and Max will answer. Well, I really don't have a proper question, but I think I know you are working on this data, and I'm sure more things will come, and looking forward for the results. And I see really interesting to be able to compare with previous ones, because we have a timeline that makes the statistics much more interesting. So good job, and looking forward for more things to come.
Okay, so it looks like it will be okay right now. So let's see how we can get some data about IPv6 and see whether it's being deployed. And just to start with a smile, Sherlock Holmes wrote this in a novel. It's a capital mistake to make some theory before one has data. And so we need to get some data. And one thing is basically when you need to measure the IPv6 deployment is basically what can we measure, and basically which kind of data source we can have. So type of data, for instance, kind of an easy one, that how many IPv6 internet users is there in the world. We can have, for instance, at what Facebook is doing in application measurement. Of course, now it requires a specific app, and you will get an app bias. For instance, if you are using a mobile app that only runs on iOS device, obviously you don't measure the Android. And as iOS devices are typically more expensive than iPhone device, than Android device, you will get more richer country. You get a bias, and we see a lot of bias everywhere. What you can do, that's a browser measurement. It's basically checking on the server side, on the web server side, how many people are coming over IPv4 or IPv6. And you don't have any specific requirement there, except that typically, again, on mobile computer, you use app and not so much browsing. We can as well look at how many ISPs are doing IPv6 worldwide, and that's basically what Max has talked about. And we get information there from RIPE and others. We can have as well have a look about the routing table over the internet, how many IPv6 prefixes there into the BGP global routing table. But we need to take care. I mean, if you have a small ISP having only 1,000 customers, it doesn't count. If, on the other hand, if you are a level 3 or Cogent or any tier 1 connecting all the ISP, that's much more important, of course. We can as well measure how much IPv6 content is there. For instance, how much web servers can be reached over IPv6. We can as well try to measure at some vantage point how much traffic, meaning bit per seconds, are doing IPv6. Looks sensible, right? For instance, we can do it at Internet Exchange Point like AM6. Now, if you look about the data source now, we talk about the data type, now where we can get the data. From the browser data, of course, you need to get a big website and make the data public. So thank you so much for Google, APNIC, as well as Facebook. It's now starting to release this data from a few weeks now. Allocated IPv6 prefixes, that's easy. We can get access to the RIPE in the other area. So again, easy. Global routing table, yeah, we can get access thanks to roadview.org. Content is a little bit more tricky now. We can get the list of the top 1 million websites from a website called Alexa. Then if we get the list of URL, we can issue query DNS for the quad A to see whether they got an IPv6 address, and then we can issue a real HTTP connection to there and see whether it's working, because not all the time it's working. Traffic. Okay, for instance, you can get a look at the AM6 or DKIX Internet Exchange Point. But don't forget, if you look about the V6 number there, it's pretty low. It's below 10%, simply because most of the big content providers, specifically the video ones, so the Google, the Facebook, the Netflix, representing a huge amount of traffic, typically are using local cache in the ISP. So the traffic to Google, Facebook, and so on never go to AM6 normally. So, and typically ISP do not give the number. They only do it on a face-to-face meeting, and they say we cannot propagate information further. Because typically ISP, typically in my country, in Belgium, sees more than 40% of the traffic being IPv6. Okay, and even if you think about the content, so indeed in Alexa, you can get a free top 1 million website, which is global, worldwide. So now if you want to see something per country, okay, everything that finished, for instance, .nl is obviously from Netherlands, but there are many top domains like .com, .net, .org, then how can you attribute them to a specific country? Specifically now, the WIS database with GDPR is becoming private, so we see no information anymore. And of course, some top-level countries like .cd, .to, .io, Indian Oceans, right? They are basically for websites not based in those countries. For instance, I'm from Belgium, so there is even a youtube.be. It's not Belgium, right? So it's California, obviously. So basically in this, we try to measure the content served by the country. So how many organizations in Netherlands, Belgium, Italy are serving content over IPv6. On the other hand, you can pay Alexa, which is part of Amazon, a fee to get the top 500 sites per country. And then this is pretty correct, but it's measuring the content seen by the country. So for instance, it will measure which kind of content this is seen by Netherlands viewers. And of course, that's again a bias there, because Alexa is a plugin that you install in your browser, and it's mostly on desktop. I don't think there is Alexa for mobile computer or for mobile handset. So you have a bias there. And just to show you the example of the difference between the content in the country, which is on the left-hand side, and the country as seen by people based in Netherlands here. If you look on the right-hand side, that's the content as seen. Of course, there's the Google, the YouTube, and the Facebook. more surprising is Vyncke.com, which is the Facebook base out of Russia. I don't understand why, but it's okay. On the left-hand side, there's the content served by organization based in Netherlands. And of course, no surprise, right? Booking.com, which is a Dutch company, is number one. You will not be surprised as well for number 4. If I guess it, that's also a typical Dutch industry. So let's start and showing the data. So you can get this data, and basically on my website, I mean, I do it on my spare time, and I don't get any revenue out of it. So that's only open data that I can get. So for instance, we can get this very simple graph based on the numbers from Google, but also I got the numbers from APNIG, I got the numbers from Akamai, and recently as well from Facebook. And you can click on the graph. But that's just a graph for one country. So what it will do now is to mix and compare countries. And you see on this graph 5 or 6 different countries, different colors. And you see, for instance, and I will do brag a bit about my own country, the top red line is from Belgium, where we reach about 50% of IPv6 deployment about 1 year ago. But you see other countries like this. We were talking before about Sky Broadband, which is in a kind of red-purple in Great Britain, which is started a long time ago as well. And just to tease Max, we just left the room, of course. We see Italy in the green, which is basically below 0, right? So anyway, if you look about the content, so that's the content served by Netherlands, right? It's the Booking.com and so on. And it is the graph on the top 50. Just to give you some explanation there. But another website, which is run by my employer, which is sixlab.cisco.com, is able there to pay for the Alexa paying list. And it is on the top 100 in green, as seen by Netherlands. How many Netherlands people go to a website? More than 120, this is the green line, are V6 enabled. And the red line is basically not IPv6. So still, the Dutch people are going on the top 100. They basically go to something like 350 websites which are not IPv6 enabled. And you've seen way too many metrics, and Stephen will talk about shortly about another matrix, which is basically about the DNS request, as we seen by the key route. So can we try to blend them? Because one metric per se is not enough, does not represent the complexity of it. So basically, can we make out of whiskey and other drinks a nice cocktail? And yes. So I worked with a student from École Polytechnique of Paris years ago, and what we were trying to do is trying to find a formula, and it's not perfect, but it's better than nothing, where basically we say 1/4 to give you point per country. It's about the numbers of transit autonomous systems, so tier 1 or tier 2 ISP, ratio on the country, which is in the maximum worldwide, plus 3/4 of the geometric mean of the percentage of content which is available and the percentage of user being able to reach the internet. Again, divided by the maximum worldwide. And it gives you this kind of map here. And based on the numbers, it's number between 0 and 10. And we see, not a big surprise, North America is kind of pretty good. We see as well Northern Europe being pretty good. More surprising maybe for many of you, it's South America that started 1 year, 2 years ago to develop heavily IPv6, so they are really, really good there. And then what can I say, right? So we again see Africa, alas, being a little bit late. But we see some Middle East moving forward, and of course India being pretty strong with Reliance, which is a mobile operator. So, can we use the past to predict the future? Obviously not, right, in real life, but can we try to do it anyway? So, for instance, if I put on the same website the Google numbers of users doing V6, and we try to do some prediction, if we use a linear regression, obviously it does not fit so much the curve, right? So we cannot do a linear regression. So if you use a quadratic regression, so basically x squared plus x plus a constant, it's a little bit better. And this is, in this case, it's no more for the global, it's only for my country, Belgium. So it looks like it's nice. But typically, on a regression, the more coefficient you are adding, the better, right? So what about going to a third order? Then okay, it does not fly, right? Because if you use a third order, in about 2-3 years, there will be minus 20% of internet users in Belgium doing V6. So it's not good. The best one on this case is really to use what we call the logistic curve, also called S-curve, because it has basically a S form or S shape. This curve is basically assuming there is a maximum deployment. And of course, once we reach 100% of users using IPv6, that's the maximum. So that's basically can go higher than 100% and can only increase and never decrease. So that's basically what many people are using in this kind of environment. So for instance, for the worldwide user here, we can assume that in 2 years we will be about more than 45%. Again, assuming that the past can predict the future. And basically, I will terminate on this slide. Do not forget the data that you see can be biased. Quite often for IPv6 is biased whether you are a mobile or you are a desktop, whether you are an enterprise being hidden behind a proxy for the web traffic can be manipulated or even shown on a specific light, pretty much like any data. So nothing specific here for IPv6, but don't forget this. And I don't know whether there is any question from you, Alvaro.
Yes, does anybody has any question on the chat? If not, I see really interesting all the the data you have, all the information we can get from your website. I would like, I see there is big differences, um, on depending on the country or where you're looking at, but it's still a question we got a lot is IPv6 happening already? And from your data and your information you get, would you say that it already started to happen? And if so, when was around the moment that you think you saw things moving forward?
Yeah, I think IPv6 is happening, right? If you look about this graph coming out of 6lab, but it's not happening everywhere. And it's really what I see, it's based on the country. It's always very hard for a first ISP in a country to make the jump. And as soon as you see one ISP doing it, it's quite often mobile or cable because it's somehow easier for them. Then you see the other one. Look about this guy has done. One argument that Max cited is that what kind of technical argument can I expose to my non-technical management? Having the fact that, hey, look about my competition in this country, which is smaller, has done it, or is larger, so it costs more, and then done it, it helps a lot. And what I've seen is that in many countries, there are kind of a relationship at the technical level among competition, like in US or in other countries. It's the emulation effect is triggering. So once the countries start, it usually go very fast.
Okay, that's interesting. Thank you.
Okay, welcome.
Now, somebody's asking for your email. Which email? You show the email in the presentation. The email is in the presentation, so you can download the presentation and it will be there, Oleg. Okay. Now we're moving to the next speaker. Stephen is going to talk about 6 years of IPv6 on Atlas, the RIPE Atlas service we run here on RIPE NCC, and the KRoot server, KRoot DNS server we also are in charge of. Also, Eric is asking about the next release of the IPv6 security book. It's a good one, but I don't know if it's going. You're planning? No, seems no. Yeah, Eric's is saying that there is no plans and security hasn't changed that much to have a full new version. Okay. Also, people's asking about the IPv6 support from top applications. Do you have data on the supporting application? No, there are no statistics or data on that. And also about statistics on IoT devices. No. IoT is not really internet. They're usually private clouds and private networks, so it's not easy to measure what they are doing. Yep.
Okay, hey, so good morning. My name is Stephen, and I'm going to be running over some of the data that we have here at the NCC. In particular, I'm going to be running over a few years of data that we have from about the RIPE Atlas platform and from the RIPE Atlas platform and about the K-root service that we also run here. In the slide title, I say twiddle 6 years because in reality the RIPE Atlas data is a little less than 6 and the K-root is a little more than 6, but let's average out and go for the middle. So I've split this talk right down the middle. So if you have RIPE Atlas questions, you should feel free to jump in and interrupt me via Alviro. And in the second half, I talk about the K-root. So let's dig straight in and go into RIPE Atlas. So RIPE Atlas is a measurement platform that we run here at the NCC. We have thousands of probes hosted by people around the world, mostly on a volunteer basis. You should totally participate by following that link if you're not already a probe host. I'm also not a salesman, so please use whichever measurement platforms you want to use. But the neat thing with this is that it's a free platform and you get a little device that you can plug in and then you can do pings and trace routes and DNS lookups and so forth from anywhere in the world across this platform. But by virtue of being hosted in people's home networks, we get a sample of home network connectivity also, which is an interesting data point. So let's dig in first with a question. One of the common data points that people discuss, and Eric pointed at a lot of this data, is what things look like from the perspective of the CDNs. The CDNs attract a lot of traffic, and they have enabled a lot of IPv6 over the years, which is great. It's the common, like Google's data, for example, is perhaps the common one that people refer to. And we've seen that growth bump up maybe year on year, doubling as we move forward. Has that been reflected in the fleet of Atlas probes that we have out there in the wild? And if we look at the entire fleet, the fleet continues to grow. It's a slow kind of growth, and we currently have about 10,000 probes consistently connected to the network that are actually doing measurements. This is not always a stable set, like new probes arrive and new probes go away, never to be seen. But in terms of the total number of probes with V4 and V6, we're at around about 10,000 probes. The set of probes that also have IPv6 is growing slowly, but perhaps not growing at the double year-on-year rate that you might expect from some of the CDN data. But nevertheless, up is still good, progress is still good. We're at around about 1/3 of the probes currently have IPv6. In terms of network coverage, in terms of ASNs, we are at a similar kind of level. And we're very, very consistent on this. We're very, very, in a particular sense, we're very, very flat on this. We've been very consistent with this over the years. The growth isn't tracking the CDN numbers, but that's probably a side effect of the platform itself. We tend to hand these probes out to the sort of people who come to RIPE meetings, and we tend to be hosting RIPE meetings in and around Europe. The sorts of people who go to things like ENOG meetings and C meetings and IETF meetings, etc., are also the kind of people who might host these probes. So we're generally co-located in the parts of Europe and parts of North America that already have IPv6. So we have a bias in our data. The upshot of that is that we have really good coverage of the IPv6 network if we want to measure that. So the platform is there, and the platform has V6, and we have good IPv6 coverage. So let's take a quick look at the measurements. So people use the platform to measure arbitrary targets of their choosing, usually over ping and trace route, and they'll often do DNS lookups to resolve names around the world and see where people are tampering with DNS queries. And there are various others, but most of the traffic is basically these. So since we know that IPv6 deployment is on the rise, are people also running more IPv6 measurements is a valid question. And the answer to that one is kind of a, well, we're alarmingly consistent. It turns out that apparently in 2014, the proportion of measurements that we were running over IPv4 and IPv6 is approximately the same as where we are in 2018. That's kind of an interesting result because I would expect that number to have changed. To be clear, this is the number of measurements in terms of the measurement specification that's generating results at any one point in time. This is not the number of results that are being generated or the number of targets that people are measuring against or the number of probes that people are using as part of their measurement. This is strictly person A has a measurement set up to run pings against a particular destination, for example. If we dig in to one of them, and let's take DNS traffic as an example, this is the protocol family that is carrying the DNS query, not the DNS query itself, then what we see is that we do have an increase in IPv4 and IPv6 measurements, which is good. The number of measurements is going up. They are basically rising along with each other. They're correlating strongly. The interesting part is that the IPv4 measurements, and we see this again on the pings and the trace routes, people are more likely to run large targeted measurement campaigns over IPv4 than they are over IPv6. That is an interesting data point that deserves a little bit further study before I make any distinctly strong conclusions about that. But I'm willing to squint at these graphs and say, well, maybe people are still thinking of IPv4 as the default and not thinking about running their targeted measurements over IPv6. Maybe that's something that people should be thinking about more often. Maybe that's a problem. Maybe it's not a problem. Maybe it's a ton of people running measurements to the same target. One thing that I'm going to try and do is flatten down some of these numbers to get a better understanding. Looking at the DNS queries, on the other hand, this one is really interesting because it turns out if we look at what people are querying for using the Atlas platform, we have a lot of people who are consistently running measurements to resolve A records to get those IPv4 addresses back out of the DNS system. But on the quad A side, to pull those IPv6 addresses out of the system, we're apparently only running on the order of 10 to 15 measurements per day. Note that this is a log scale on the y-axis, so those A query numbers are way higher than the quad A query numbers. That feels like a gap, except that obviously the ping measurements and the traceroute measurements will do a DNS resolution of their own. It's just not carved out as a separate DNS query. But it's interesting nonetheless. Maybe people should be paying more attention to this, given that oftentimes they're going to be hosted on a third-party platform or a VPS system or a CDN that may play games with the DNS to attract traffic. It's probably useful to understand where that traffic is going. So the answer to the original question of do we see measurements going up, yes and no, we see measurements going up. But there is still more on the IPv4. Clearly IPv4 is still the focus for RIPE Atlas, which is maybe a sad story for the IPv6 stuff, but I hope to try and encourage more usage. So I'm going to split brain this talk and switch over to the K-root now. And the K-root is our part of the root server family. There's a link there that points to the various sites that we host. We even have some high-level statistics on there that you can go and download yourself. Like, a lot of this data is not strictly private. All of our K-root instances are dual stacked. All of these are anycasted, so we attract queries from resolvers over IPv6 and over IPv4 around the world. And of course, we have data. And some of that data, you also have data. You can go and pull a lot of this. So in terms of the actual traffic increase, let's start from a similar graph. Let's get to the graph in the next slide. Similar question, right? So CDNs are reporting HTTPS requests, but that's HTTP traffic. DNS traffic is different, and DNS architecture is different. So on the K-root, we're going to be measuring what the resolvers are speaking rather than specifically clients. But it gives us an indication of what networks are doing and how networks are actually deploying their v6. Once a network is actually given connectivity to the users, do they also set up the DNS resolvers? Because these are going to be different people with different teams and different focuses. So similar kind of graph to the graph at the start on the fleet of Atlas probes. We have a count of IPv4 requests coming in, and we have a count of IPv6 requests coming in. And what we do see is that there has been that gradual increase of requests coming in over IPv6, which is great. We see growth. We see a not entirely dissimilar growth pattern to what people like Google, etc., show already. So if I switch over to percentages, it's maybe a little clearer. The split is that around about 15% of the queries that we receive in the k-route are received over v6. That's within a distance, within a close distance of what Google's numbers show. It's within a close distance to what Facebook's numbers show, for example. So that's a similar level of traffic. There will be a correlation between which networks are generating that traffic with what the CDNs see on HTTP. I haven't done that correlation yet, but as I say on the other data, I'm going to dig a bit more into this also. So growth is good. K-route traffic is being handled over v6, which is awesome. I will be looking into which networks and which countries are generating that data. Obviously, the set of resolvers is a much smaller set, so some of that will be a little less stable versus having a million eyeballs that are accessing your content. But this is still a strong indicator for who's running v6 and when things are changing, and maybe sometimes even when things are breaking. If somebody suddenly drops off the network, all of these are signals for when things are going well and when things are going badly. So the next part then, not looking at the protocol families, but looking at how people are using this, what people are actually querying. Now that we're at a point where we have legitimate IPv6 deployments out there, and now that we're at a point where software developers have to take it seriously, especially if you're interacting with Apple apps, for example, now that we're at a point where it's in a lot more places, do we see more Quad A queries? Has that changed significantly on the k-route over the years? And this story kind of gets very similar to the Atlas measurement story, which is we see the number of Quad A requests going up generally, which is great. Maybe the mixed part of that picture is that in terms of the ratio of Quad A to single A queries, those are actually very, very similar. I'm going to be optimistic about this graph and say that those are basically on a level. So what we're not quite seeing yet is that as v6 deployments are maturing, that we are reaching that Quad A to single A parity, which maybe is maybe not a concern, maybe it's a red flag, maybe a lot of those A queries are noise, maybe there's a lot of spam. I'm not entirely sure what's in that ecosystem. But this is one of those data points where it would be nice to see that ratio changing. So that's a mixed picture. That's a yes and a no. And I've said all of this. And of course, the behavior in the k-route is likely to be different, very likely to be different to a DNS service or a DNS resolver that you're running in your own network, or people who are handling different parts of the DNS zone tree. The behavior that we see in the k-route is likely to be its own beast. One interesting data point to lead out on, though, is if I look at the protocol that queries are arriving on, broken down by the query type, what we see is that at the top there, if I take the full set of Quad A queries, around about 25–30% plus of those are carried over IPv6. The existence of IPv6 encourages Quad A queries. I guess that could be I'm not a DNS person, so somebody maybe out there can answer why that's the case. But it's not beyond the realm of possibility that people who have v6 are also not going to be flattening those Quad A's. Equally, it could be weird bugs on people's weird assumptions about how DNS behaves. But if I cluster these into groups, we have the Quad A's at the top there, which is the clear outlier in this particular data set. And we have this second cluster in the middle, which is on a level with the percentages that we saw earlier. Around about 15% of those NSA and SOA records are being served unambiguously over whichever protocol they arrive on. And then there's this other cluster at the bottom of queries that are much more likely to come in over IPv4, and those are MX and pointer records and CNAMEs. And that's kind of interesting that the protocol family changes the DNS behavior. So that's a strange surface. So takeaways from all of this. What do we get? Like, this is a mixed bag, right? We have two network stacks, and maybe we need to get to a point where people are better at monitoring these. Maybe we need to get to a point where people think of IPv6 as a first-class citizen. And when I say people, I mean, like, obviously a lot of people already do, but I'm thinking about things like ops runbooks and TDD and people's uptime monitoring and those kind of things, like making sure that those are in the bag as things that people are looking at, like, from day one. We know that we have an uneven surface, so that's not surprising. Networks move forward at different paces. We've known this for many years. That implies that countries move forward at different paces. That's also been very clear in the numbers. But it's also clear that protocols move at different paces. And although the common one that we talk about is HTTPS, there's a lot of interesting data out there, including RX stuff and this some of this K-root data that suggests that this is a moving surface. And hopefully everything's going up and to the right, but we will move at slightly different speeds. So final note, go please measure the IPv6 internet. And thank you, that's me.
Okay, thank you, Stephen. Really interesting to see, and also seems like there more information will come. So looking forward for that as well.
Yes, I will have there is a RIPE Labs article which has a lot of the same graphs that should be published on labs.ripe.net today, if I get everything lined up correctly.
Okay, good. And people saying in the chat that they didn't even heard about it before, so we are getting more people
Awesome.
interested in helping on this.
Cool.
There's some question on the chat. If not, we are going to finish here just to thank the three speakers. I think really interesting information. We saw different point of view, measuring different things on to see how IPv6 is happening today, the level of implementation, the traffic, the services from different points of view. We are going to do a 15 minutes break. No, no. Okay, no break then. We are a little bit late, so yeah, let's make it just 3 minutes to switch speakers and moderators. And thank everybody for being here, and keep enjoying the Educa IPv6.